Hello and welcome to the next tutorial for the Ultimate Turn-Based Battle System for Unity. In this video, we are going to take a look at the Create Hero tab inside the custom Ultimate Turn-Based Battle System window. The Create Hero tab is used to create and edit playable hero characters for your battle system. A hero is not just a sprite on the battlefield. A hero contains level data, HP and MP growth, stat growth, affinities, skills, equipment support, status effect handling, defend logic, animation handling, and all the data needed to participate in battle. For this tutorial, we will stay on the Create Hero tab. The Create Hero tab creates a hero data asset and a hero build prefab. The hero data asset stores the actual hero information. The hero build prefab is the game object that will be spawned and used during battle. This is important to understand. The hero data asset contains the values and settings. The hero prefab contains the runtime components and visual setup that use this data. Now let's go through the tab from top to bottom. At the top of the tab, you can find the Load Hero button and the Clear button. The Load Hero button allows you to load an existing hero data asset back into the editor. This is useful when you want to edit an existing hero instead of creating a new one from scratch. When a hero is loaded, the tab restores the hero's sprite, portrait, name, max level, growth settings, affinities, and assigned skills. The Clear button resets the tab back to its default values. This is useful when you want to start creating a new hero and remove the current inputs from the editor. Next, we have the General section. Here you can assign the hero sprite. The hero sprite is the main visual sprite that represents the hero during battle. When the hero prefab is created, this sprite is assigned to the sprite renderer on the character child object. This is the sprite that will be visible on the battlefield. After assigning the sprite, the editor also displays a preview of it directly inside the tab. This makes it easier to check if the correct sprite has been selected. Below the hero sprite, you can assign the hero portrait. The portrait is separate from the battle sprite. It can be used by the Battle UI to display the hero in panels, menus, results screens, or other interface elements. For example, the battle sprite might be a full body character sprite, while the portrait could be a close-up face image. Below that, you can enter the hero name. The hero name is used for the hero data asset, the generated prefab, and for identifying the hero in the battle system. Try to use clear names because these names will also help you organize your hero assets later. Next, we have the Level Settings section. Here you can define the max level of the hero. The max level controls how far the hero can level up. For example, a classic RPG hero might have a max level of 99. Another game might use a smaller level range, such as 20 or 50. The editor supports a large range, so you can decide what fits your game. The max level is important because the Create Hero tab generates level-based lists for EXP, HP, MP, and all additional stats. This means the hero does not only store one HP value or one strength value. Instead, it stores a full progression table from level 1 up to the max level. Now let's talk about growth settings. The Create Hero tab contains growth settings for EXP, HP, MP, and all additional stats from the Stats tab. Each growth section has a preview curve. This preview curve helps you understand how the value grows over the hero's level range. For example, if you are editing HP, the preview curve shows how the hero's HP increases from level 1 to the max level. Each growth section has a minimum value and a maximum value. The minimum value is the value at level 1. The maximum value is the value at the hero's max level. For example, if HP has a minimum value of 50 and a maximum value of 999, the hero starts with around 50 HP and reaches 999 HP at the maximum level. The editor then generates the values between those 2 points based on the selected growth preset. The first growth setting is EXP. EXP defines how much experience is needed to level up. The EXP growth list is used by the level system component. When the hero receives experience after battle, the level system checks whether the hero has enough EXP to reach the next level. If enough EXP is available, the hero levels up. The level system also makes sure the hero cannot go below level 1 or above the max level defined in the hero data. Next we have HP. HP defines the hero's hit points for each level. The HP system component reads this HP list from the hero data. When the hero's level changes, the HP system updates the maximum HP based on the current level. The HP system also handles taking damage, restoring HP, clamping current HP between 0 and max HP, and notifying other systems when HP changes. This is important for battle UI updates and gameplay logic. Next we have MP. MP defines the hero's mana or magic points for each level. The MP system component reads this MP list from the hero data. When the hero's level changes, the MP system updates the maximum MP based on the current level. The MP system also handles consuming MP when skills are used, restoring MP, clamping the value, and notifying other systems when MP changes. So HP and MP are both level-based, but they are managed by separate components. HP is handled by the HP system. MP is handled by the MP system. Below HP and MP we have the additional stats section. The stats shown here come from the Global Stats tab. For example, if your project uses Strength Defense, Magic Strength, Magic Defense, Speed and Agility, those stats will appear here. Each stat gets its own growth settings. This means every hero can have a different stat curve. For example, a warrior could have high strength and defense growth, but lower magic strength. A mage could have high magic strength and MP growth, but lower defense. A fast rogue could have high speed and agility growth. This is where you can define the identity and battle role of the hero. Each stat growth section uses the same type of setup. You can define the minimum value at level 1. You can define the maximum value at max level. You can choose a growth preset, you can adjust variation, and you can randomize the seed. The growth preset controls the shape of the curve. Linear creates a steady growth from the minimum value to the maximum value. Ease in starts slower and grows faster later. Ease out grows faster early and slows down later. S-curve creates a smooth progression that starts slower, grows stronger in the middle, and slows again near the end. Exponential creates stronger late-game scaling. Logarithmic creates stronger early growth. JRPG creates a more RPG-like curve with stronger early growth, a more stable middle, and some endgame scaling. These presets make it much easier to create different hero progression styles without manually typing values for every level. The variation value adds controlled variation to the growth curve. This can make the generated values feel less perfectly mathematical. The seed controls the variation pattern. If you click Randomize, the seed changes, which creates a new variation pattern while keeping the main settings such as minimum, maximum, preset, and variation the same. When the hero is saved, the editor builds the full level list from these settings. It also makes sure the values stay safe and do not decrease unexpectedly. This is useful because most core stats should usually grow or stay stable as the hero levels up. Now let's talk about affinities. The Affinities section shows all affinities from the Global Affinities tab. For each affinity, you can choose the hero's resistance type. For example, a hero could be normal to physical, weak to fire, resistant to ice, or absorb lightning. The available resistance types are the same ones used by the rest of the battle system. Normal means the hero receives regular damage. Weak means the hero takes increased damage. Resist means the hero takes reduced damage. Block means the damage is cancelled. Repel means the attack is reflected. Absorb means the hero is healed by that affinity instead of damaged. These affinity settings are saved into the hero data asset. At runtime, the affinity system component reads this information and stores it in a dictionary. When the hero is hit by a skill, the battle system can ask the affinity system how the hero reacts to that skill's affinity. This is what allows heroes to have elemental weaknesses, resistances, immunities, absorption, and repel behavior. Next, we have the skills section. Here you can assign skills to the hero. To add a skill, click the Add Skill button. This creates a new skill entry. Each skill entry has a skill data reference and an unlock level. The skill data reference is the actual skill that the hero can learn. The unlock level defines when the hero learns that skill. For example, a mage could learn Fireball at level 1, Ice Spear at level 5, Thunderstorm at level 12, and Meteor at level 30. If you no longer need a skill entry, you can click the Remove button to delete it from the list. These skills are saved into the hero data asset. At runtime, the skill system component checks the hero's current level and determines which skills are learned. If the hero's current level is equal to or higher than the unlock level, the skill is considered learned. If the hero is below the unlock level, the skill is not learned yet. This makes it possible to create natural skill progression for each hero. Now let's talk about saving the hero. At the bottom of the tab, you can click Save Hero. When you save the hero, the editor creates or updates a hero data asset. The hero data asset stores the hero sprite, hero portrait, hero name, max level, EXP growth, HP growth, MP growth, stat growths, generated level lists, affinities, resistances, and skills. After the hero data asset is saved, the editor also creates or updates a hero build prefab. This prefab is the actual hero game object used by the battle system. If a prefab for the hero already exists, the editor updates it. If no prefab exists yet, the editor creates a new one. Now let's look at the structure of the generated hero prefab. The root game object is named after the hero and uses the hero tag. This root object contains the main hero components. The first important component is the hero data holder. The hero data holder stores a reference to the hero data asset. This is the connection between the hero prefab and all the data that was created in the editor. Many other hero systems use the hero data holder to find the hero's data. For example, the level system, HP system, MP system, stat system, affinity system, and skill system all rely on the hero data from this component. The hero data holder also has a custom inspector that displays a small overview of the assigned hero data, such as the hero name and max level. Next, the prefab gets a level system. The level system manages the hero's current level and current EXP. It reads the max level and EXP requirements from the hero data asset. When the hero receives experience, the level system checks whether the hero should level up. It also triggers a level changed event. Other systems, such as HP and MP, can respond to this level changed event and update their values. Next, the prefab gets the HP system. The HP system manages the hero's current HP and max HP. It reads the level-based HP values from the hero data asset. When the hero takes damage, the HP system lowers the current HP. When the hero is healed, it restores HP. It also makes sure HP does not go below 0 or above the current max HP. The HP system raises an event when HP changes, so UI and other systems can react. Next, the prefab gets the MP system. The MP system works very similarly to the HP system, but for MP. It reads the level-based MP values from the hero data asset. It handles consuming and restoring MP, clamping the value, and raising an event when MP changes. This is used when heroes use skills that cost MP, or when items and effects restore MP. Next, the prefab gets the stat system. The stat system calculates the hero's current stats. It starts with the base stat values from the hero data for the current level. Then it adds runtime flat modifiers such as status effect buffs or debuffs. It also adds equipment bonuses from the equipment system. So the final stat value is built from base stats, status or buff modifiers, and equipment modifiers. This is important because a hero's strength, defense, magic strength, magic defense, speed, agility, or any custom stat can change based on level, equipment, and status effects. The stat system also supports breakdowns, so the inspector can show where bonuses come from. For example, a stat could have a base value, an equipment bonus from a weapon, and a flat bonus from a strength up status effect. Next, the prefab gets the affinity system. The affinity system reads the hero's affinity and resistance setup from the hero data. It provides the current resistance type for a given affinity. For example, the battle system can ask the hero, "How do you react to fire?" And the affinity system can return normal, weak, resist, block, repel, or absorb. This system is used during damage calculation and battle reactions. Next, the prefab gets the equipment system. The equipment system stores the hero's equipped items. By default, the system supports equipment slots such as weapon, shield, and armor. The custom inspector shows the available equipment slots based on the equipment type data. It also validates the equipment type. For example, a weapon can go into the weapon slot but not into the armor slot. The stat system can then read all equipped items and apply their stat bonuses to the hero. Next, the prefab gets the skill system. The skill system reads the hero's skill list from the hero data. It checks the hero's current level and determines which skills are learned. This allows the battle UI to show which skills the hero can currently use. A hero can have many skills assigned, but only the skills with an unlock level equal to or below the current level are considered learned. Next, the prefab gets the status effects system. The status effects system manages all active status effects on the hero. It can apply HP changes, MP changes, stat buffs, stat debuffs, percent-based effects, damage over time, healing over time, and duration handling. For example, poison could subtract HP each turn. Regeneration could restore HP each turn. Strength up could add a flat bonus to the strength stat. Defense down could subtract from defense. The status effect system also handles durations like until next turn, number of turns, random duration, or until the end of battle. When a status effect is removed, the system can also remove the stat modifiers that came from that effect. Next, the prefab gets the defense system. The defense system tracks whether the hero is currently defending. When the hero uses the defend action, the defense system can mark the hero as defending. Incoming damage can then be reduced using the defend multiplier from the calculations data. When the defend state ends, the system can clear the defending flag again. This allows defend to work as a simple but useful tactical action during battle. The generated hero prefab also contains a child object called character. The character child contains the visual and animation setup. It has a sprite renderer for the hero sprite. It has an animator. The animator uses an animator override controller that is created for this hero when the hero is saved. The animation clips that come from this override controller already contain animation keyframes that animate the hero sprite assigned in the Create Hero tab. This means that the hero sprite is not just placed on the battlefield as a static image. The generated hero already has working base battle animations using the selected hero sprite. So all hero sprites are already animated by default. Of course, you can still customize this completely. You can edit the generated animation clips directly with keyframes. You can replace them with sprite sheet animations. Or you can create entirely new animations, including more advanced setups like bone animation, depending on how your character artwork is built. This gives you a ready-to-use animated hero immediately, while still keeping the animation setup flexible for your own project. Next is the character animation handler. The character animation handler is very important because it connects animation events back to the battle state machine. For example, when an attack animation ends, the animation event can call the handler. The handler then tells the current player turn state that the attack animation has finished. The same idea applies to take damage animations, block animations, repel animations, absorb animations, defend animations, item use animations, spawn animations, and despawn animations. This allows the battle system to wait for animations and continue the battle flow at the correct moment. When the hero is saved, the editor also creates an animation folder for that hero. It creates or updates an animator override controller based on the battle character base controller. This makes it possible for every hero to use the same general animation structure while still having their own animation clips. For example, each hero can have their own idle, attack, take damage, defend, absorb, and other battle animations. The editor also creates or updates helper objects called Turn Indicator Origin and Target Indicator Origin. These are placed based on the hero sprite bounds. The Turn Indicator Origin is placed near the bottom of the sprite. The Target Indicator Origin is placed near the top of the sprite. These origins help the battle system and UI place indicators in a clean and consistent way. For example, the turn indicator can appear below the hero, while the target indicator can appear above the hero. This saves time because you do not need to manually create these helper points from scratch for every hero. The hero prefab is now ready to be added to the hero dictionary and used by the party manager. Once the hero is part of the party setup, the battle system can spawn the hero during battle. In the next tutorials, we will continue with the other tabs of the Ultimate Turn-Based Battle System window and look at how they work together to create complete turn-based RPG battles. Thank you for watching. If this video helped you, please leave a like and subscribe to the channel for more tutorials and updates about the Ultimate Turn-Based Battle System.